In this video, we will learn how to generate a binary tree using linked representation. We have seen two representation, array and linked representation. So I'll be showing it for linked representation. So for generating a binary tree, we can start generating nodes from a root node. First we can create root node. Then we can create left child and right child. But when we are creating a left child and right child, we should know whether the left child and right child are there or not. Like this is a full binary tree or complete binary tree. In this, every node is having both left and right child also. But here, some nodes are not having left child, some are not having right child. So first of all, we should know whether a child is there or not there. If it is there, then we can create and attach it. So this is the main thing that we have to take care. So this is the main thing that we have to take care. We have to check if the child node is there, then we will create it. Then one more thing. We will generate it level by level. So first we will create root, then we will create the nodes of first, second level, then third level, then fourth level, so on. So that same procedure we can use it for a full binary tree also, that we can ask a child is there or not. But here we need not ask. So I will show you the procedure how to generate this tree in a linked representation. So for generating a tree using linked representation, we need a queue data structure. So I'm just drawing an array to show that it's a queue. I will take a queue. So this queue will have front pointer, rear pointer, all the mechanism you know already. So I don't have to explain you its mechanism. Just we will insert and delete the element from the queue. Now let us start the procedure. The very first step is create root node. So create one node and make root point on that node and insert the value, then make this as null. So assume that this is the only node now. This is the first node and this is the only node. Suppose the address of this node is 200. So that address, insert it in the queue. So we need addresses. We don't want value 5. We want address of a node. Insert it here. So this is the initial work that we have to do. So once again I repeat, take a queue, create root node, insert the address of root node in the queue. Now we are ready for repeating procedure. So now the steps are repeating steps. So if you look at one step, one or two steps, you can understand rest. Let us see what we have to do. Take out this address from the queue, so 200, and make some temporary pointer p point on that address. So p is pointing there. Standing on that node, ask whether it is having left child. So yes, as per the tree that we want to create, yes, it is having a left child. Your left child is there. So then create a new node with the help of temporary pointer and insert the value, whatever the value is. Then set these pointers as null. Then as this is having left child, so make this p's left point on this node. And suppose the address of this node is 210. Then this new node, insert it into queue. Now its child is inserted. So if child is there, then insert it. Now next, for the same node P, ask whether this node having value 5, is it having a right child or not? Yes, it is having a right child. So as per the tree that we want to create, there is a right child. So okay, take the temporary pointer and create a new node and insert that value 6. Make these as null and the P's right child point into this one. Suppose the address of this node is 230, then insert that address 230 in the queue. That's all. This has finished one step. So what was the step? I'll just repeat it quickly. We took the pointer from the queue and make p point there and ask whether left child is there or not, and we created it. And insert its address. Right child is there or not? Yes, create it and insert its address. Same thing will be repeating again and again. So I'll be creating the entire tree. But before going to the next step, just one thing I want to tell you. Here we have to ask whether left child is there or not. If it is there, then we create. Again ask right child is there or not. If yes, then create. So instead of asking, we can simply take the value of left child. And we can put a mark that if the value entered is -1, then child is not there. If it is other than -1, let us say positive, then the value is there. Let us continue and create all the nodes and generate the entire tree. I will do these quickly because already I have explained you. Next step, Take out the next address from the queue, that is 210, and make the pointer P point on that. So this is the node. Then being here asked, what is the value of the left side? Left side is -1. So it is -1, don't create anything. Then take the value of right side. The value is 9. So create a new node with the help of temporary pointer T. Then enter the value, make this as null. P is right on this one. Suppose the address of this node is 250. Insert 250 into the queue. So we have finished with left and right. Now take out the next address from the queue, that is 230, and make P point on that node. And ask the left side value. Left side value is a 3. So okay, create a new node with the help of temporary pointer T. Insert the value, make this as null. Then P's left should point on this one. Suppose the address of this one is 300. Then insert the address into the queue. Then ask the right child. Right child is -1. So if the value is -1, don't create anything. So we have finished with left child as well as right child. Then next step. Take out the address from the queue 250 and make P point on that one. So this is 250. Ask the left value. It's there. So that is 4. So create a new node with the help of temporary pointer T. Insert the value, make this as null, and make P's left point on that one. Suppose the address of this node is 350. So insert 350 into the queue. Then ask the right child. Right child value is there. Yes, it is 2. So it is not -1. So take the value and create a new node with the help of temporary pointer. Insert the value and make this as null. P is right on this one. And suppose the address is 370. Then insert the address 370 into the queue. Then continue. Take out the address from the queue, that is 300. So make P point on that one. Ask for the left child, it is -1, don't create. Then ask for the right child, -1, don't create, because there are no left child and right child for this one. Then take out the next address from the queue, that is 350, and make P point on that one. Ask for the left child, it's not there. Ask for the right child, -1, not there. Then move to next. So take out the address 370 and make P point on that node, 370. Ask for the left child, -1, it's not there. Ask for the right child, -1, it's not there. Then take out the address from queue. There is nothing in the queue. Queue became empty. So stop. So end of the procedure. And we have generated a tree in heap. And this is the root which is holding the entire tree. So we have learned the procedure how to generate a tree with the help of queue. Now next we have to write a function for generating a tree. So I will show you the program code for generating this tree with the help of queue.